Okay, the gear terminology, gear nomenclatures. The terminology of the spur gear, terminology of gear tip is in the figure. You can see the various terms used in the study of gears have been explained below. For example, you can see here the first whenever the gears drawing, we have to notate where is the pitch circle. Okay, PCD. So that imaginary circle actually, which is not we can see by our naked eye. When there are two gears mesh each other, gear to gear get contact and which push loop that form one circle. That circle is called pitch circle diagram. This is the flank region is shown here. This is the face. This is the pitch circle. Now from the pitch circle, now this above region is all addendum and below the pitch circle is called addendum. See here they have mentioned addendum and addendum. This is there, no? Then face width. This is called pitch top line. These are the circles, addendum circles. Width of space, width of space. There is small fillet is formed here. That is called fillet radius. There is little bit clearance also there. This is called clearance. This is the tooth thickness from this point to this point. Okay, and this tooth thickness we can measure by using a special caliper called gear tooth caliper. By ordinary caliper, which is not possible to exact take the thickness of the tooth. So we require one special caliper called gear tooth caliper. Okay, that one instrument required. Then circular pitch from this point to the adjacent teeth of this another tip. Okay, then whatever distance is there, you can find by measuring, that is called circular pitch. This is a dedendum circle. This is a clearance circle. So the bottom line, so top line. Clear. Is there any one word which is not you understood? Just let me remind. Then I'll show you the video. Out of this all terminology, which is thing you are not understood so far? Face width, this is from here to here. Okay, the distance of entire tooth length. I think we cover almost all things. Now you can watch video. So तुमको आने much reminder दिया था.
Nomenclature of gear. In this video, we are going to see about nomenclature of gear.
This is the actual gear machine is happening here. So one gear is this, one is pinion, and one is the gear maybe. And this gear to gear get mesh here. So this mesh in gear, here there will be a point contact between the two gears tips, and this tips form that contact form the circle called pitch circle diagram.
Pitch circle, an imaginary circle which by pure rolling action would give the same as the actual gear. Addendum, the radial distance of the tooth from the pitch circle to the top of the tooth. Dedendum, the radial distance of the tooth from pitch circle to the root circle of the tooth. Addendum circle, the circle drawn to the top of the teeth and is concentric with pitch circle. Dedendum circle. Circular pitch, the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. Clearance, the radial distance from the top of the tooth to the bottom of the tooth in a meshing gear. A circle passing through the top of the meshing gear is known as clearance circle. Total depth, the radial distance between the addendum and dedendum circle of a gear. Tooth thickness, the caudal width of the tooth measured along the pitch circle. The width of space between the two adjacent teeth measured along the pitch circle equal to tooth thickness. Profile, the curve formed by the face and flank of the tooth. Face. Top line, surface of the top line of the tooth. tooth measured parallel to its axis. Fillet radius, the radius that connects the root circle to the profile of the tooth. Bottom lap,
Understood all these things? So the same thing they have, whatever I told you, they are shown in the video also. Plus there are some definition here. What is the pitch circle? Is a imaginary circle which by pure rolling action will give some give the same motion as the actual gears. That is called pitch circle. Next is what pitch circle diameter. We have a pitch circle diameter also. The diameter of the pitch circle. The size of the gear is usually specified by the pitch circle diameter. Whenever the gear size is designed, it's based on the specified by the pitch circle diameter. It is also called a pitch diameter. It is equal to the module times the number of the teeth. So what is the module? We'll see that. Pitch point, the common point of the contact between the pitch circles of pinion gear. That is pitch point. Pitch surface, the surface of the rolling disc which the machine gears have replaced at the pitch circle. Then pressure angle or angle of obliquity, the angle between the common normal to the two gear teeth at the point of contact and the common tangent at the pitch point. So this definition, the pressure angle exactly is formed in the at the pitch circle diameter. See, it's angle between the common normal to the two gear tips. So both driver and driven tips are getting meshed, and that form the pitch circle. At that, this pressure angle forms. Those two gears tipped at the point of contact and the common tangent at the pitch point. So there will be one common tangent from the pitch point. So it is usually denoted phi. The standard pressure angles are 14.5 degree and 20 degree. These are the standard angles also. If you don't remember, you can keep some idea of 14.5 to 20 degree. Then addendum, the radial distance of the tooth from pitch circle to the top line, top tooth. Addendum circle drawn through the top of the teeth and is concentric with the pitch circle, that is addendum circle. The addendum, the circle drawn to the root of the teeth is called the root circle. And circular pitch, the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth is already discussed circular pitch. Then circular pitch PC is the pi d upon z. Pi m module z. See, this is the way it is derived. So pi m is equal to d is equal to mz, where d is the diameter of the pitch circle and z is the number of teeth on pitch. So basically, this module is defined based on this. Okay, so that is the diameter of pitch circle and z is the number of teeth on field. So basically, this is the equation. So module means it's a ratio of the pitch circle diameter and pitch circle diameter in millimeter to the number of teeth. So n means it's a mm. Okay, don't get mixed. So the ratio of pitch circle diameter in millimeter is equal to number of teeth. That is m is equal to d upon z. So d is the diameter of pitch circle diameter, and z is the number of teeth. If they both are given, you can easily find out the ratio module m. Okay. If m is given, diameter is given, you need to find how many teeth on that each gear you can find out. M must be m double d as d double. So you just multiply the z to the n, which equal to d. Then this diameter to pitch, the ratio of number of teeth of gear to the pitch circle diameter. Now, what is the diameter to pitch and modules? Diameter to pitch is a inch system. Okay, where all gears are in the range of inches. Then inch cutter, everything inch. They are following diameter to pitch. The ratio of number of teeth of the gear to the pitch circle diameter. So it is a ratio of number of teeth to the gear to the pitch circle diameter. So diameter pitch PD is equal to T upon number of teeth upon diameter. This diameter pitch may be given or may not be given. May be given, then you will follow, put that in the equation, find out the what should be diameter of pitch. The number of teeth. Then clearance, the distance, the the radial distance from the top of the tooth and the bottom of the tooth in a machine gear, mostly it is a machine gear. A circle passing through the top of the machine gear, known as a clearance circle. It's very simple. Total depth, addendum plus dedendum is the total depth. So the radial distance between the addendum and dedendum circle of the gear, it is equal to sum of the addendum and dedendum for a full depth gear, that is 2.25 millimeter. This you can calculate easily for the total working depth. Working depth, the radial distance from the addendum circle to the clearance circle is equal to the sum of addendum of the two machine gear. Now thickness. Tooth thickness, the width of the tooth measure along with the pitch circle. So the pitch circle, from the you have to measure it the thickness. Tooth space, caudal thickness, the width of the space between the two adjacent teeth measure along with the pitch circle equal to the tooth thickness. Backlash, the difference between the two space and the tooth gears, tooth thickness between the tooth space and the tooth thickness as measured on the pitch circle. So this is called backlash. It is mostly difference between the tooth space, how much tooth space is there, and the tooth thickness. That is called backlash. Face of the tooth, surface of the tooth above the pitch surface. So wherever the face of the tooth area, it's a surface of the tooth above the pitch surface. Top line, sufficient of the top of the tooth. No. So, top line, the surface of the top of the tooth. Very simple. Then flank of the tooth, the surface of the tooth below the pitch circle. Face width of the gear tooth measured parallel to its axis. Profile, the curve formed by the face and flank of the tooth. The last one is fillet radius, the radius that connect the root circle to the profile of the tooth. So now it is everything ready-made across. Here we cut everything maintained as per the standard. Now according to the pitch line velocity mostly they are not using, but you should have some idea. According to the pitch line velocity of gear, the low velocity less than 3 meter per second, medium velocity 3 to 15 meter, and high velocity it should be the greater than 15 meter per second. According to the types of gearing, the external gear is shown here, and if in the case of it is internal gear, you watch this video. See, now we are discussing all external gear.
In this video, we will
inside.
discuss about the internal gear. Let us see
So these are the internal gear.
The internal gear for gear is in internal gearing, the gears of the two shafts clash internally with each other. Concrete mixture machine is the application of the internal gear.
So concrete mixer is the application of internal gear. There are internal gear. Without where siding us. There are cast iron. Okay. This is our internal gear example. Next is the gear of the shaft meshes externally with the gears in a straight line actual figure. The rack is a greater of infinity. Back on pinion. What is my back on pinion? Such type of gears is called a rack and pinion. The straight line gear is called rack and circular wheel is called a pinion. So it's straight line rack and it's called pinion. A little consideration will show that with the help of the rack and pinion, we convert the linear motion into the rotary motions and vice versa as shown in the figure. This rack and pinion means that the rack is having infinite radius. There is no radius for it. It can be any long elastic. It's driver for the wheel system. Okay, now, what is by helical gears, herringbone gears, and bevel gear? These are modern industries. We require such type of gears. Helical gears, bevel gears, spiral gears, miter gears, and hypoid gears and form gear. Helical gear, bevel gear, spiral gear, miter gear, hypoid alternating, and worm gear. I'll just cover. So the internal gears, you see the now helical gears. Helical gears and spur gears, you can see the only the difference is the tips are in inclined position. Okay, but the manufacturing process is very lengthy compared to the spur gear. Here we require special machine, and we have to calculate the helix angle and everything, like how screw angle is we are calculating like this. Helix angle is required. There is a lot of calculations. So tip of this type of gears, in helical gear, the teeth of these gears are cut at an angle to the axis of the shaft. And the helical gears can right hand or left. So one should be a right hand side, other should be a left hand. In a pair of helical gears, one should be right-handed and netting gears should be left-handed with the same helix angle. The helix angle is should be same.